me on Friday itself, so I didn't have much time to prepare the slides. So I just prepared only the basics of solar energy. I hope that, like Sir said, I'll share my contact details and you guys can contact me anytime to address your queries. So I'll just give a brief introduction about the company I work for. So I work in ARKA Energy. The company is a startup. It's a US-based company, and it's a solar solution provider. So we believe in providing end-to-end solution, wherein we start from modules and we have the electronics as well as the energy metering and the gateway. So I'll speak more on that as we move forward. So like I said, the company main mission is to provide innovative solutions for a sustainable future. And the products which are there are Power Roof, Power Gazebo and Power Packaging. So I'll just give a brief introduction, as you all are very young and you need to know about the process, how the industry works. So ideally it starts from concept development, wherein something new is happening in the market. So we do all the market analysis, and a lot of brainstorming happens. So the end product of all the market analysis and brainstorming is the company or the team, which is called as a product management or product development team. It comes forward with a document called MRD, which is market requirement document. So once the document is ready, it is moved to the design team, design and development team, to convert the MRD, which is market requirement document, to a PRD, which is called as project requirement document. So what the design team does is it takes all the requirements and they come up with design solutions for the concept which is available in the MRD. So what they do is, how do they design it? So they start with the simulation and then they do all the hardware prototype and testing in the hardware prototype and testing. So next we move on to the testing phase, wherein the developed prototype is tested, wherein you have certain set of guidelines which are required. So if you say you have your mobile phone, so it has to go through rigorous testing. So it should be customer friendly, right? So you have a lot of testing available, and then all those testings are covered in few documents such as design verification test and functional verification test. So in the meanwhile, what you can do is you can run these tests internally if you have the required facility, or else you can give the product to external labs to run these tests. Okay. Next, the product will be moved to a reliability and compliance stage, wherein the product is tested for safety and a lot of standards which are coined by the government agencies. Okay, and then it moves on. Once this stage is finished, where you receive all the certificates related to the product, it will be moved to manufacturing phase, wherein bulk production happens. So this is one of the products which is available at ARKA Energy. So we have a very unique product which is called a tile. We don't call it a module. It is a tile, and we have two types of variants. One is the actual PV tile, which has the solar cell and generates all the required power, and the other one is non-PV tile, which does not have the PV cells, but it fills in the aesthetic part. So if you see on the left hand side, so you have this setup. So this is actual working setup, wherein the whole roof is designed so as to accommodate both PV and non-PV type. So if you see here, some part the maximum. So how it is designed is designed to optimize the amount of energy which can be harvested. So if you see this part of the roof, it has a lot of shading, right? so not much of power can be harvested. So that side, most of this side, mostly the non-PV cell will be non-PV. This side is populated with non-PV types, and the rest of all will be populated with PV types. But again, it is aesthetically pleasing. So you cannot, if you see, you cannot really make out which is the PV part and which is not the non-PV part. Okay. So like I said, this is what is called a power roof, wherein the home roof itself is converted to a power generating asset. And this part, what you call, is called a power gazebo, wherein if you see in general home, you have structures which people usually go and rest, use it for leisure. So rather than having an open structure, we have populated with solar cells so that energy can be generated from that as well, and as well as you are using it for your recreational purposes. So coming to the actual topic for today's session. So I'll just give a brief introduction for solar energy. So the rays which comes from sun, they are divided into three types. One is the beam radiation, which does not get diffused or directly falls on the PV panel. The other one is diffuse radiation, which comes in contact with the particles in the atmosphere or gets reflected from the objects on the surface of Earth, and then gets reflected to the photo panel. The other one is some of the rays get absorbed, okay, and few of the rays gets reflected back to the atmosphere. So it does not go falls on the panel, but it gets reflected back to the Earth's atmosphere. That is called as albedo radiation. So the total amount of to speak in solar terms, the total amount of radiation what is received on the solar panel is called as global irradiance. So this is a combination of direct radiation or direct radiation, and the diffuse radiation and the albedo radiation. Okay. So any questions so far? So if you look at some of the solutions, home solutions, you guys must be aware of it. There are currently two types of popular home solutions available. One is the off-grid solution, and one is the on-grid solar solution. So what happens to the off-grid solution? You have the solar energy produced, it falls on the solar panel, it goes to the inverter, and inverter is connected to a battery as well as the loading home loads. So the excess amount of energy which gets generated from the solar panel, there's no use of it, so it goes waste. Okay, so what happens is in the off-grid solution, whatever amount of energy is produced by the panel, it either gets filled in the battery and used in home. But usually, if no loads are running and your battery is also full, that amount of energy goes waste. So it's not nothing is being done about the energy. But in case of on-grid solar solution, the amount of the excess energy can be fed to the grid. So it meets the demand and gap requirement. Okay. So in that case, you have the net meter as well, which is a bidirectional meter. So what happens is in the net meter, the amount of energy which is drawn from the grid, in case of during night time when there is no solar, so you will draw the energy from the grid. So that time the net meter comes into picture, wherein it usually the amount of energy which is fed to the grid as well as the amount of energy which is consumed from the grid can be measured. So to talk about the grid tied solution, which at ARKA Energy we are working on. So this is the block diagram of it. So it has the main components of the grid tied solution is you have the panels, you have a charge controller, you have an inverter. In most of the cases, these two are combined together. So there is no separate charge controller, and then you have inverter. So both are combined. Then you have the inverter itself. You have a DC backup, as well as you can connect any DC loads. Then you have your from the inverter, you know, right? So the inverter is basically a DC to AC converter. So from the inverter, you have this AC distribution box, and you have your net meter, and then you have the connection to the grid. So if we talk about the PV technology or the module technology, so this graph basically shows the evolution of the PV technology. So we started from a silicon module, so we have different types of silicon modules. Silicon monocrystalline, we have polycrystalline modules, thin films, and then we move on to amorphous silicon, and then gallium arsenide silicon. We have hybrid modules. We have organic modules. So different types of modules are there. So this is a lab report. So we have NREL. NREL is a US company, US lab, which has been into PV from a long time. And according to their report, we have been able to produce a module which can give an efficiency of 40.6%. So this is the latest big breakthrough. So the earlier of 2023, they were able to produce a module based on hybrid junction design. They were able to achieve 40% of efficiency. So in normal use, what we see in all the residential solutions is we either use monocrystalline silicon based modules or polycrystalline silicon based modules, which give an efficiency of maximum of 18 to 20%. So if we can bring out modules which will give efficiency of 40% or 50%, that will be very huge achievement in the field of solar. So coming to added few images related to solar. So like I said, monocrystalline as of now economically feasible. These three are the economically feasible modules and silicon based modules. Monocrystalline has 19% and it can go up to 20 or 22%, and polycrystalline maximum is 18%, and thin film is much lower. So if you see, thin films can be used in this type of arrangement. Now you see we have a lot of modern homes, and earlier also this, I think, if you go to the rural side, you will see these types of tiles on the roof of the homes, so that that can also be turned as energy generating roof. So similarly, this is also one example for thin film arrangement, and that is called as mangrove tiles. So right now we see that setup as well. That's also kind of popular these days. And then the other one is space application, wherein monocrystalline or gallium arsenide cells are popular. Okay, so I'll move on to the electronics part. So one is the PV part, one is the electronics part, wherein electronic part has the your inverters, your gateway, and the protection device. So we'll talk about the protection device first. So when the PV gets generated, the generated energy is in DC form, right? So we need to protect why do we need protection devices first of all? We need to protect our devices, right? All the inverter and the loads, they are very expensive. So what we do is we have an AC distribution box and DC distribution box. So the energy, the DC energy coming from the PV, which is DC. So to protect our inverter, we use something called as DC distribution box, which consists mainly of surge protection device and MCBs and fuse. And similarly, we have ECDB, which is connected between the inverter and the AC loads, which protects our the loads. If you see hospitals and all, the loads are very much crucial, right? So the ACDB plays a huge part. All our protects our electronics, the TV, the AC if you are connected, all those things gets protected. More the inverter part. So inverter technology basically, all the installation, solar installation, what you see. So mainly divided into three parts. One is the central, either you can use a central inverter, you can use a distributed or a string inverter, what we call. The other one is micro inverter. So in the central inverter, what happens is all the solar panels, if you see here, you have two strings of solar panel. All the panels are connected to one single inverter. So this is a, what do you think? This is an advantage or disadvantage? Can anyone answer? So what happens if there is shading in one single panel? Okay. The thing in solar is whenever there is a shading on one single panel, that drives the whole string. Okay. So in case of shading, the complete energy from the whole setup comes down, and then we do not get the optimal energy. Okay, so that's the drawback in central inverter. So what they did was they came up with, dividing strings depending on string inverter, and they use inverter for each string. So out of two strings, I'm using two inverters. But this again has a disadvantage wherein I have one more string, and suppose I have the same shading effect on one single panel, this whole string power comes down, right? So I don't want that to happen. Then we moved on to the latest one is micro inverter technology, wherein each individual panel is driven by inverter. So the shading or the optimal energy generation, that is taken care in the micro inverter setup. But it has its own drawback. The price wise it's very high, so not very economical solution. So at ARKA we are working on micro inverter. So if you see here, this is how the module looks like. We have a conventional module, and we have a micro inverter which will be connected. So this is a micro inverter on top of which a conventional module comes. Okay, so this is the block diagram of micro inverter. This is actually a two-string, two-channel micro inverter. So I have some few panels of PV panels here on each channel, which is input to a DC optimizer. And then the output, stable output from the DC optimizer is given to a inverter, and then it goes through a filter before being connected to the grid. And all my controls are driven by a microcontroller, or as of now we have all your ARM processors, microcontrollers, all that can be taken care of. So let's talk about the topology. So we have types of inverters. So it can be either a two-stage inverter where you have two separate stages. So if you see here, inverter is basically a DC to AC converter, and it can be divided in two stages. So here that's what we are doing. We have two stages. One is the DC to DC converter, and then a stable DC input is then connected to the AC output. So that's what the block diagram shows. So we have a DC to DC converter, you have a constant voltage here, and then you have a DC to AC converter. And then if you're not going for a DC to AC two-stage conversion, you also have topologies which have a single-stage conversion as well. Then, like I said, you have a gateway device. So gateway device is why you use a gateway device is you need to maintain your data, right? So the amount of energy which is generated by TV, as well as the amount of energy which is output to grid. So all those data you need to store it onto your server. So that's where the gateway comes into picture. Sometimes even the inverter, all your mobile phones, you get your updates regularly, right? So that for the inverter, that is how it is taken care in the solar solution. So you have a gateway which gets which is connected to the main server, which gets input from the server, and then all your updates is sent to the inverter. So we have a term which is called for your update, which needs to be sent. It's called as OTA, over the air updates. Okay. So how do we communicate between the gateway and how do we establish communication between gateway and the inverter? We use cable wired communication to RS485. We use Bluetooth, Wi-Fi, or something called as Modbus serial communication between the gateway and inverter. So the other one is other electronics is net meter, which I explained earlier. It's a bidirectional device to basically measure the amount of energy consumed from the grid as well as the excess amount of energy fed to the grid. Next hardware part is solar storage. Storage technology. You have different types of storage options. The most common one is electrochemical, which we see as batteries. And we have mechanical, we have electrical. Electrical is basically super capacitors, but it's higher, it costs much more than the batteries. Then we have thermal solutions as well. Basically, the hydrogen fuel cells, so they are categorized there. And so, like I said, there are different types of battery technologies: the lead acid, nickel cadmium, and lithium ion. So lithium ion is more favored due to the weight and the energy capacity, storage capacity. So this table shows the sizing as well as the weight of different battery technologies. So as I was talking about the standards earlier, which came under the reliability and compliance. So these are all the standards which the solution, which each product has to go through. So if you have a combiner box, which is the ACDP and the DCDP, it has to go through its own set of standards. These are UL basically talks about all the protection standards. So a combiner box has to go through UL 1741. Which certification gives all the protection, so it is surge protected or lightning protected, all that is included in the certification. Next is the charge controller and the inverter. So you have UL 1741, so that it complies to all the grid codes and meets all the protection. So we have software solutions as well. So software, like I said, it deals with the simulation studies and report generation. So suppose somebody has to wants to install a solar solution on their rooftop, what they do is, if they approach ARKA Energy, we do a simulation study on the particular location, generate report, seeing whether, what capacity of solar energy should be stored, and what are the electronics that should be used, what type of inverter to use, what type of storage to be used, what type of panels to be used, how much panel to be used, which direction should the panel be. And we do a lot of analysis, basically the shading analysis as well as the loss estimation. Estimation also consists of cable loss, oil loss, or dirt loss. All those parameters are considered while estimating the loss. And then we also give out the return on investment analysis in the estimation. So what is return on investment? So basically, whenever you invest some amount on your on anything, what you do is you expect something, some profit in return, or else at least you should be able to break even the amount of capital which you have invested. So this is also one of the analysis and one of the major analysis right now. So that's what I've written. Profitability is calculated after reaching the break-even period, which indicates basically how much, when do you get back the amount of money which you have invested in your solution. Yeah. So the last point being your initial investment and return on investment also takes into account the annual operations and maintenance cost which for certain period, say for 25 years of period your project is running. So in that 25 years of period, each year how much of O&M will be O&M is put aside for your maintenance of the system.
Thank you.